All right, so we had actually done a little bit of this a couple days ago, and I'm going to show you this word. It's called empirical formula, okay? Now, if you, on your book, I'm going to use the book in just a minute for an example question, but let's do this thing again. Let's take a look at a real chemical formula. A real chemical formula. Oh. All right, so let's try one. Water is a real chemical. Glucose is a real chemical. Here's another one. This is the stuff you use, table sugar, C12H22O11. Here's a chemical, table salt. Okay, now, so we're okay on that. That's nothing new. Those are chemical formulas. But for over 200 years, when chemists were trying to say, hey, what is this stuff? Chemistry is a study of matter, right? So they said, what is this made of? And so they did all kinds of things to try to figure it out. They weigh it. They would see if it conducts electricity. They would do all kinds of things. Remember when you did the lab, if you reacted two things and bubbles came out, they had tests for gases, didn't they? You know what the test for hydrogen gas was? What's the test for hydrogen gas? The pop test, right? So, oh, see that bubbles? Those are hydrogen. What's the test for oxygen gas? You put a glowing wood splint in there, and what? If it bursts back into flame, see that? And there was another one for carbon dioxide. That was way at the beginning of the year. I showed that to you. I had made some carbon dioxide gas, and I poured it onto a candle that was in a beaker. What happened to the candle? When I made carbon dioxide, I put baking soda and vinegar together, and I poured this gas. You can't see it. And it went into the beaker. What happened to the flame? What does carbon dioxide do to a flame? Made it go out, didn't it? And so they had all kinds of tests for different things. Now, another thing they did is they might have had something that said, I think I'm going to heat this, I'm going to weigh it, I'm going to heat it, and sometimes when they heated things, it got heavier. And they said, whoa, what's going on here? And they eventually figured out that the metal was combining with oxygen in the air, and that made another heavier compound. You get that? So which was heavier, copper or copper oxide, do you think? Copper only has copper in it, right? What's copper oxide have in it? See that? Does it make sense to you? Certain metals, if you heat them, if they combine with oxygen, they're going to be heavier, aren't they? And so they eventually figured that kind of stuff out. They had electricity. They had some things they could put electricity on, it would break them apart. It would decompose them. So they'd weigh it, decompose it, weigh it again, and they did all kinds of analysis. Now, the reason I'm telling you this story is because when they did their mathematical analysis, what they would come up with was the empirical formula. Now, that's a fancy way of saying, I'll tell you what it is. Empirical formula is a fancy way of saying the lowest whole number ratio of the elements. In a compound. Now, I remember the first time I heard that word, well, I don't know what that is. I've never heard that word before. And so I'm going to, because I'm going to say it so many times, and I'll tell you how to do it, you'll say, oh, I get it now. Okay, so let's take a look. And by the way, since I ran out of space here, I'm going to put my H2O down here. Okay, you don't have to because you maybe didn't run out of space. All right, so here we go. When they did the analysis, it could only tell them there's this many of these atoms compared to this many of these atoms, okay? Hey, Zach, what are you doing? Can you put your notebook up here? I can't see what you're doing. Okay. All right. All right, here we go. Now, what if I told you that they found out about water? Another way of saying this is I know you're really good at math when you reduce things. You know how to reduce formulas? Okay, watch. Can you reduce this? What if can you divide both these by any number besides 1 and make it smaller? No. So guess what? For water, when they found the empirical formula for water, it was the real chemical, wasn't it? How about this one? What about NaCl? What if they found out for every one Na, there's one Cl? Now, what do you think? That was the real chemical, wasn't it? So you might say, I think you're wasting my time. So far, the empirical formula is the same as the chemical formula. Look at the next one. What's the empirical formula for table sugar? This is table sugar, by the way. That's the stuff you guys have in your house. What's the empirical formula? When they analyze this, what did they come up with? What can you divide all these by? Oh, I'm sorry, you can't. All right, this one's the same. I should have picked it. Can I pick a different example? Let's do this one. How about glucose? Can you reduce that? What would you divide by? 6. So what are you going to get here? Everybody see that? I meant to put a different one here. That's my fault. What I really wanted to do was, that's not table sugar. So I'll tell you, that's my fault. I am sorry. I'm going to change my example. There. This stuff right here is what they use for acetylene torches. Ever seen a torch that goes right through steel? You ever see on movies where they're trying to break into a safe and they have some kind of a torch? The chemical they use here is acetylene. They combine it with oxygen. It makes a really, really hot flame. And this is called acetylene. What's the empirical formula for this guy? Wait, we got to keep going here because this is the simplest part of the lesson, okay? What do you got? Yes? All right, you divide both by 2, right? So CH, I'm sorry. Darn, I'm making a lot of mistakes today. I'm sorry. What is it now? CH, okay? All right, sorry. Now, so sometimes the empirical formula is the actual chemical, isn't it? And sometimes it's not. And what I'd like to do is show you, let me show you something here. The last 2 pages of the chapter tell you, after you've figured out how to do this, and I'll show you how to do that today and Monday, after you figure out the empirical formula, another test can be done to find the molar mass of the real chemical, So let me show you how this works, okay? What if I told you that my analysis shows for every 1 carbon, there's 2 hydrogen and 1 oxygen. That's the empirical formula. But then I've told you that another test was done, and we found out that the molar mass was 180. Now, is this the real chemical? Okay, so look on the periodic table. What do you think? What is the mass of this guy, and is it going to add up to 180? Let's try it. How many carbons do you have there? 1. Okay, that's 12. And how many hydrogens? 2. That's 2 more. That's 14. And then 1 oxygen is 16. So what would that be? How much would this thing weigh? How much does the empirical formula weigh? And we have to keep moving, okay? We just had a quiz on this. If I ask you to find the molar mass of something, what if I told you, I need the mass of the empirical formula. What is it? 30. Okay, now, here's my question. If this guy weighs 30 and the real chemical weighs 180, could this be the real chemical? What do you think? If the real chemical weighs 180 and the empirical formula only weighs 30, could the empirical formula be the same one? All right, what do you think? No, it can't. So tell me, I know you guys are smart. How many times would I need to multiply that before it would be the real chemical? Or another way of saying is, how many times will this go into that? If what's 180 divided by 30? What's 180 divided by 30? What's that, 6? It says, okay, I know you said the ratio has to be 1 to 2 to 1, but you need more than one of these. You need more than one of those empirical units. You need how many? 6. So I go up here and multiply everything times 6, and what do I get? What's C1 times 6? What's H2 times 6? And what's O1 times 6? And that's how they done it. That's how in the history of chemistry, the analysis could tell them the simplest whole number ratio, but another test was done to find the molar mass. This guy's mass was not the same as a molar mass, was it? So that can't be the real chemical. So how many times will this mass go into the real mass? 6 times. So I multiply everything here times 6. All right, this one. This one, the molar mass was 26. Okay, so the molar mass of this guy was 26. Is this the real chemical? The empirical formula says you have 1 carbon atom for every 1 hydrogen atom. Is that going to be the real chemical? Just pretend like you don't see it over here, right? You say, wait, what's the mass of my empirical formula? How much is that going to weigh? Everybody in this room should be able to do that. What's the mass of CH? 12 plus 1 is what? Okay, is this the real chemical? You said, no, the real chemical has a mass of how much? Okay, so what's 26 divided by 13? 2, isn't that right? So what am I going to do to these? Multiply everything times what? 2, and what are you going to get? What if you multiply everything times 2, what do you get? C2, H2, yes. The what? Oh, excellent question. When they were analyzing it, they had one way of analyzing it to get the empirical formula. They had another test to figure out what the molar mass was. So if I don't tell you the molar mass, you won't be able to figure this out. But what they did is excellent question, excellent. One test showed them the empirical formula. Another test showed them the molar mass of the real chemical. My empirical formula only had a mass of 13, but they figured out the molar mass was 26. So he said, I need 2 of those, don't you? I need everything to multiply by 2. And so C2, H2. Let's try another one. This one, they found out the molar mass was 58.5. Okay, is this the real chemical? I don't know. How much does this weigh? It weighs 23 plus chlorine is 35.5, right? How much is that? How much is 23 plus 35.5? Is that 58.5? So my empirical formula weighs 58.5, and another test said that the molar mass of this is 58.5. What does that tell you? Can you put your mask up, please? What do you think? You guys, I know how smart you are, okay? I know you are. So think about this. If the empirical formula weighs 58.5, and another test, and that's a good question you had, Layla, another test was done to find the molar mass, and it was 58.5. Well, then what? What are you going to say? That is also the real chemical. So, true or false? The empirical formula is never the real chemical formula. That's false. It can be, can it? Okay, true or false? The empirical formula is always the chemical formula. That's false. You get that? So I want to teach that to you because that's the easiest part of the lesson. The easiest part of the lesson is once you get the empirical formula, if I tell you the molar mass also, I have to, then can you go from the empirical to the real chemical? Let's do one more, okay? Let's do one more. All right, so now, ready? I'll give you about 30 seconds to do this. Say, an analysis was done, and the empirical formula was found out to be CH2O. Another test was done, and it found out the molar mass of the real chemical has a mass of 90. Is this the real chemical? And is that the real chemical formula, or what is the real chemical formula? So let's try it. And everybody has, I want you to try it. If you fail, I'm okay. If you try it and you don't get it, I'm okay with that. All right, raise your hand if you're done. 1, 2, 2, 3, 4. I get close? Or you can say to yourself, you know what, I guess I wouldn't, I'm not sure how to do it. You can say that. We're doing this one right here. This is the empirical formula. Another test was done and found out the molar mass was 90. What is the real chemical formula? Did you get done, Sierra? Okay. May, you finished? Okay. All right, Zach, what do you think? Are you trying it? Okay. Okay, now let's say if you're not done, raise your hand and say, here's a question I have. If I could answer this question, I think I could finish it. What question do you want to answer? All right, are you finished? Kyle, did you get it? You got it? Okay, Zach, you finished yet? All right, what question would you like to ask in order to finish it? Okay. If you can I ask you that at least this part of the lesson, the part of the lesson today and Monday, it's on page in your book. It starts at 222. So on page 222 to the end of the chapter, that's all about empirical formula and molecular formula here. Okay, chemical formula. All right. Now let's take a look and see how you did. An analysis was done and found out that the lowest whole number ratio, that's called the empirical formula, was C1H2O1. Another test was done and found the molar mass was 90. Is this the real chemical? Well, let's take a look. How do you find the mass of this? And if you did not look at the periodic table, that's number one. If you didn't look at the periodic table, that's how you couldn't do this. How much does carbon weigh? A mole of carbon, how much? Weighs 12. How much does a mole of hydrogen weigh? 1 gram. There you go. And I have 2 of them, right? So that'd be 2. And how much does a mole of oxygen weigh? And that's 16, right? I used 3 sig figs. So what is 12 plus 2 plus 16? 30. Okay, now, this guy weighs 30, but the real chemical weighs how much? So this can't be the real chemical, can it? So what's 90 divided by 30? So if I multiply everything here times 3, it would add up to 90, wouldn't it? Final answer? C what? C3, H6. What do you think? That's kind of fun. Okay, so the last 2 pages of the chapter tell you, hey, if you know how to do empirical, I'll tell you how to go from empirical to real chemical. Get that? That's the easy part of the last 5 pages. Okay, so now what I'm going to do is, let's go over here, and let me show you how to do empirical formula. Okay, now, there's an example problem, and that's what I do like about the book. It has some nice problems here. And I'm going to take a look. I'm on page 223. Let's go to page, and if you don't have your book, I'm going to use my book, and I'll enlarge it so you can see it. And here's the question we have. Okay, now, an oxide of aluminum is formed by the reaction of that many grams of aluminum and that many grams of oxygen. Calculate the empirical formula. Now, you've never done this in your life, is that correct? I can't believe anybody in this room has ever done that, is that all right? So let's see if I can make it simple for you, all right? I'm going to show you a little trick. I'm going to get back to this in a minute. Number one, if I look at any formula, okay, this is important. This is the conceptual part. What world are you in when you look at a formula? Does this talk about mass? 2 grams of hydrogen and 1, is that what that is? Is that what those little subscripts are? Is that the world of mass? Or is it this? Or is it the world of number of particles? What does H2O mean? It means for every 2 pieces of hydrogen, atoms, for example, you get what? 1 oxygen, right? Now, since I can't visit the tiny world, what does H2O also mean? What does H2O also mean? In the little world, it means 2 atoms of hydrogen combined with 1 oxygen, right? But in the world of moles, what if I said I gave you a mole of water? Man, that is a lot of water, isn't it? Isn't that a lot of water? 6.02 times 10 to the 23rd? That's a lot of water. Then guess what this means? It means 2 moles of H are combined with what? 1 mole of O. So guess what? If you want to find any kind of formula, like empirical formula, you cannot be in the gram world. What world do you have to be in? It's a 4-letter word that means you're in the world of number of particles, which is the entire theme of this chapter, the mole world. You have to be in the mole world in order to get any kind of formula. So let's go back to our problem. And what did they give me? What's the given? Can everybody see the given? Now, what is that number? 4, what was that, 4151? Let's try it here, ready? 4.151 grams of aluminum. Now what I'm going to do is I'm going to put that there, and then what else do we know? 3.692 grams of oxygen. I'll fix the camera. All right, now you might ask yourself, why are you doing this? It's like, there we go. You might say to yourself, why are you doing this? Why did you just do that? Because what world are you in right now? Look at this right here. What world are you in? Nuh-uh. You're not in the moles. What are you in? Isn't that the mass world? Isn't that grams? You cannot do a formula in a gram world. So I have to convert grams into what? Moles. Now, didn't we just have a quiz on that? Let's try it. Ready? Get into the mole world. All right, now here we go. Now let's say you didn't understand this until now. Or let's say you're not sure. Let's try it. Ready? Let me call on somebody. Let me see, Julia. All right, ready? Before I do this problem, tell me everything you know about, remember the 3 equivalents? I'll start you out. 1 mole of aluminum equals, go ahead. 6.02
times 10 to the 23rd.
What are you going to put after that? It's on the periodic table.
Is it molecules?
No.
Molar units.
What? No.
Oh.
If it's on the periodic table, what's the smallest piece of aluminum that acts like aluminum?
Atom.
Yes, atoms. Now, equals how many grams of aluminum? And that's where we go on the periodic table. And what do you got, Julie? Help me out. We use 3 sig figs. That's going to be what?
So 26.
27? No.
27.
If I say 3 sig figs, that's going to round to 27, isn't it? Now, you should be able to write the 3 equivalents for aluminum. Everybody get that? Okay, now we're going to do the factor labor problem. Now look right here. And this is what you should have done yesterday on the quiz. What label has to go away up here? Grams of aluminum, so put it here. And what do you want to convert it into? And we said, well, if you're going to find an empirical formula, you have to be in the mole world, don't you? So I want to change grams of aluminum to moles of aluminum. Are you with me so far? Now, we go over here. Where do you find your numbers? Look, go look for them. What number is next to moles of aluminum? 1? Okay, I can do that. What number is next to grams of aluminum? There you are. Okay, now you pick your calculator up, and what you want to do is find, and we don't go below 3 sig figs, okay? We always have at least 3 sig figs. Put this in a calculator and tell me what you get. If I didn't think you could do these problems, I wouldn't teach this. You understand that? I know you can do this. Again, I want you to have at least 3 sig figs, okay? And I know what the author got when they divided, so let's see what you got. All right, Madison, what do you have when you divide those? You what?
I'm redoing it actually.
Are you, okay. Did you divide it yet? Okay, so in this case, I'm gonna not use scientific notation, so 0.15, you get 4? Okay, we can do that. So, is that what you got, 0.154? Did you get 1.54 times 10 to the minus 1? Okay, that's the same thing here. Now, ready? This is moles of aluminum. Now, I want you to do this now. See, I want you to do this now. How do we do that? Let me ask Layla, ready? We want to get rid of grams of oxygen. We're going to replace it with moles of oxygen. And all I need to do is, before I put the numbers in, tell me, Layla, tell me the 3 equivalents about oxygen. Ready, go.
1 mole of oxygen equals 6.02 times 10 to the 23rd atom.
Yes.
That equals 16.
Yes. See, you see this? It's coming. Is it coming more natural now? Now, let's go. What are you going to put here? I don't need grams of oxygen. There you go. 16. I need moles of oxygen. There you go. There you go. I now do the same thing. Give me 3 sig figs. All right, Daniel, what do you have for this one?
0.231 moles of oxygen.
Okay, now, right now, you said, well, thanks for showing me how to do that, but that's a mess. That does not help me. And by the way, you say, oh, I got it. My final answer is AL 0.154 O 0.231. Yeah, I've seen equations. Have you seen formulas like that ever? Have you ever seen formulas like that? No. I said empirical form is the lowest whole number ratio, right? These are not whole numbers. So what I'm going to do is I'm going to show you a math trick. And mathematicians throughout history have figured this out. If you have 2 numbers, 3 numbers, 10 numbers, and they look ugly, I call these ugly looking numbers, and you want to find the lowest whole number ratio between those numbers, you do this little math trick. You take the smaller one. Which one's smaller? Does everybody know which one's smaller? 0.153, right? And divide both of them by the smaller. Divide both of them by the smaller. So watch what I'm going to do. Ready? Take the smaller, this is smaller, and divide both of them by the smaller. And you'll see something kind of, it almost looks like magic. It's not magic, it's mathematics. Okay, now, look what happens. Drum roll. La, 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 la. What's 0.154 divided by 0.154? What? Isn't it 1? Now, ooh, that's looking closer to a whole number ratio, isn't it? That's a whole number. And what are you going to get here? What do you get here? Who's done this? Let's see. Madison, what do you have? What's 0.231 divided by 0.154? Can you see the screen all right? Okay, 0.231 divided by 0.154. What is it? Now, I'm going to tell you, these were ugly looking numbers. These are looking better, aren't they? We're almost done. We are almost done. Which one's not a whole number yet? Which one's not a whole number? An integer, how about that? Which one's not a whole number? This one, right? Now, here's my clue. Ready? What do you have to multiply 1.5 to get a whole number? What do you multiply by to get a whole number? Uh-oh, that's a problem. What do you multiply 1/2 to get a whole number? 2? What do you multiply 1/2 by to get a whole number? What if you multiply half times 2? What do you get? Don't you get 1? What do you think you multiply 1.5 times to get a whole number? Everybody get that? So, ready? I'm going to multiply you times 2 because that'll give me the whole number called 3. But wait a minute, you have to maintain this ratio. If you multiply this guy times 2, you have to multiply this one times 2. And now I am finished. My analysis, I went from the gram world to the mole world. I took some ugly looking numbers and made them look not so ugly, and my final answer is, ready? Look at drum roll. Blah, 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 blah. Every 2 moles of aluminum, you'll get how much? 3 moles of oxygen. What's your final answer? Al2O3. I did it. We found the empirical formula of this chemical. Yes?
I understand everything except for when you multiply the factor label.
Oh, this one?
So when you multiply it, I would get like,
Remember, anything that's in the denominator, you have to divide by it.
right, so I get that, I get the whole, like, but when I would get my answer, I don't understand why you took away the like times 10 to the.
Okay.
the decimal point.
Okay, 1.53 times 10 to the minus 1 is the same number as this. Remember in first semester, if I said, put this in scientific notation, you would have said, whoop, 1.53 times 10 to the minus 1. Now, the only reason that I sometimes have you do a scientific notation, which is fine. I think for this one, maybe why don't you take it off of scientific notation for right now? How about that? Now, if you take it off of scientific notation, go back to normal, you'll get this number here, 0.154. Now, even if you did do it in scientific notation, remember when you divide by a scientific number, you have to put it in parentheses? That may be something you forgot. That's a good question you had. No one's asked me. I like how you did that. Let's take it off of scientific notation. Now, did you get this divided by that? See if you get that number there. And this divided by that. See if you get that number there. Okay, yes. Yes, Layla.
Can you go back and explain why you multiplied by 2?
Okay, by multiplying by 2? Okay. The empirical, what's the definition of empirical formula? The lowest what? Whole number ratio. Is this a whole number? Yes. Is this a whole number? No. So I'm getting close though, right? I had some really bad looking numbers there. They weren't whole numbers at all, were they? At least I have them looking nicer. What do you have to do to 1.5 to make it into a whole number? Multiply by 2. Now, because you have to have this same ratio, 1 to 1.5, it's just like in math. If you multiply this guy times 2, you have to multiply the other times 2. Get that? And so my final answer is, for every 2 aluminums, there's going to be what? For every 2 moles of aluminum, there are going to be 3 moles of oxygen. And my final answer is, I found it. I found this chemical, I now know is what formula? What's the formula for this chemical? Al2O3. Now, if we do another one, I think you're going to catch on. Can we do it? Let's do one more, and I think you're going to catch on to this, all right? So let me find another one here. Okay. I'll tell you what. Let me look back here. Okay, here's one. Okay, I'm on. This is if you want to see the question, I'm back here at the end of the chapter, number 57, and let me go ahead and make that bigger. Now, what I'd like you to do? Maybe if you're sitting close to somebody, if you could sit with somebody and say, work your way through this. 57 says a compound was analyzed. Oh, dang it, not that one. Yeah, let's do 59. Let's do 59, sorry. 59 is the one that you can do right now, okay? Let's do number 59. A 0.5998 gram sample of a new compound has been analyzed and found to contain the following masses. Okay, it has that many grams of hydrogen, that many grams of oxygen. Calculate the empirical formula of the compound. Okay, so what we want to do is, can you stay in the gram world and get empirical formulas? No. So what we have to convert grams into what? Moles. Okay, let's go ahead, sit with somebody, and I'll go ahead and do the problem. I'm gonna hide the camera for you for a minute. Can everybody go ahead and write, if you don't have your book with you, can you at least write those two numbers down? Write these two numbers down and see if you can, I'm sorry, this has three elements, doesn't it? That's okay, you do it the same way, So if you at least, I'll leave this up right here until you guys are ready. So go sit with somebody. We're doing number 59. It has hydrogen, it has carbon, hydrogen, and oxygen. Ooh, 3 of them. You do it the same way. Now, since she was taking a quiz, Juliet, you had to be the captain. So you turn around, and you're going to be the leader of this group. Because she was taking a quiz, and you're still learning, okay? Is that right? So you take over. You can do it, Julia. You take over, and you help them. And you're going to say, well, we got to change grams into what? Moles. So show them how to do that. And make sure they can see what if you're writing, see what they can do. We'll get hurried a little bit. I'd like to get this done before we leave. That's about 4 minutes from now. So did everybody write down the number of grams of carbon, number of grams of hydrogen, the number of grams of oxygen? Did everybody write that down? Okay, now, how about converting? Do you know how to convert it into moles? Factor label. Do you know how to convert it into moles? What's this one?
The questions.
Oh, for the lab?
Yeah.
Okay. Now, you keep looking at the screen, but once you write down the 3 masses, then you should do the problem just like we did the other one, okay? So once you write down the 3 masses, you don't need to look at the book anymore. All right. Now wait, when I say write down the 3 masses, you need to have some space to do factor label problems, don't you? Okay, here Julie, look at me. Look at Julie. Look. See, didn't we have to write down the masses and leave some room for a factor label problem? Do that. So put the 3 masses, skip some space, mass, skip some space, mass, skip some space. Right now, you should have 3 different masses written down, and you're doing factor label problems on them, and you're going to change grams into what? You're going to change grams into what? Wait, you guys are doing 59? Yeah, you're doing 59. Change grams into moles, okay? You have about 3 more minutes. All right, they're going to finish this problem, and I'm going to walk around and help them, so that's the end of the video today.